Now we have completed our table for addition modulo 12. Let's see if some of the properties of addition still hold. What properties do you know? Do you remember? Yes, Ronnie?
The closure property.
Okay, closure property. Let's see if it holds true in addition modulo 12. What does the closure property state, Jay?
The closure property of addition states that the sum of any two numbers is found within the set.
Okay, so remember, we're dealing with set Z12. So we're dealing only with the digits numbers 0 to 11, right? So closure properties, according to J, if we take any two elements and get the sum, will we find this within our Z12? Okay, can you give me any two elements of Z12? Yes, Venan?
We can have two elements,
1 and 2, okay. 1 plus 2, what do we have here? 3. Is 3 an element of Z12?
Yes.
Okay. So if we take any two elements and get their sum, will we always land at an element within set Z12?
Yes.
Therefore, we can say that Z12 is closed. Right? What other properties do you remember? We have closure. Yes, Erica?
We have commutative property.
Okay, commutative property. Let's check for commutativity. And what does that state? Changing what? What do we change in commutativity? We change the...
We change the order of
Okay,
the numbers.
but we arrive at the same
Answer.
sum. All right. So that means A plus B will we end up in
B plus A.
B plus A in modulo 12. All right. Another two numbers for A and B. Quickly, give me. Kim?
3 and 5.
Okay. Is 3 plus 5 congruent to 5 plus 3 in modulo 12?
Yes.
What is 3 plus 5? Looking at the table, 8. So 8 is congruent to 8 modulo 12. Are you sure?
Yes.
Let's check. Does 12 divide the difference 8 minus 8?
Yes.
So 12 divides 0. Therefore, we can say that this exhibits commutativity. So actually, if you do that for all elements, you will find out that addition modulo 12 is commutative. What's the next property? Yes, Maritel?
Associative property.
Okay, associative property. So let's check for associativity. And what does that state? If here we change the order of the addends, here what do we change, Ruby?
We change the grouping.
Okay, grouping. So that means there should be at least 3. So A plus B plus C. Let me group here B and C. Is it congruent to?
A plus B plus
Okay. In modulo 12. Let's see. Give me 3 values for A, B, and C. Yes, Mary?
2, 1, and 8.
2, 1, and 8. Okay, let's check if 2 plus 1 plus 8 is congruent. Okay, so here what do we do first? We add 1 and 8, and that will give us 9. On this side, we have 3 plus 8. We'll check if they are congruent modulo 12. What is 2 plus 9?
11.
What is 3 plus 8?
11.
Okay. So if you do that for every group of 3 elements in Z12, we'll always find out that the sum is still the same. All right. What's next? What other properties do you remember? Ronnie?
The identity property.
Oh, the identity property. Okay. What's the identity element for Z12? Yes, Fran?
The identity element in Z12 is 0.
Why?
Because any number
Any number.
add to the identity element, which is 0, then it is congruent to a given number.
The
or A.
given number. Okay. Okay. All right. And we have another one. Another property. Yes, Maritel?
And the last property is inverse property.
Inverse. All right. What's the inverse of 1? In other words, what number will you add to 1 to get the identity? But our identity element is 0. So, what number will you add to 1 to get a 0 in modulo 12? What's the inverse of 1? Yes, Kim?
The inverse of 1 is negative 1.
The inverse of 1 is negative 1, but then we don't have negative 1 here. So what number will you add to 1 to get a 0? Can you check the table? What number will you add to 1 to get a 0? Yes, Gerence?
11.
Okay, 11, let's see. 1 plus 11 will give a 0. And, or 11 plus 1 will give us 0. Alright?
Yes.
So the inverse of 1 is 11. Now, what is the inverse of 2? Can you check and look at the table? What's the inverse of 2? What number will you add to 2 to get a 0? Yes, Miguel?
The inverse of 2 is 10.
Okay, let me check. The inverse of 2 is 10. Will we get 0 here? All right. So the inverse of 2 is 10. How about the inverse of 3? The inverse of 3 is, Philip?
Ma'am, 9.
Okay, the inverse of 3 is 9. Do you see a pattern?
Yes.
If I ask you, what's the inverse of 10? 2. Without looking at the table, what's the inverse of 7?
5.
What's the inverse of 6?
6.
What's the inverse of 8?
4.
Okay, so all of these elements have an inverse within the set. Going back to Z5, what if I ask you, what's the inverse of 3 in modulo 5?
2.
Yes, it's 2. So do you see a pattern?
Yes.
Okay, what's the pattern? Ronnie?
The pattern is that when you add the inverse, the number and its inverse, it will be equal to the number of elements in the set.
Okay, it's actually equal to the modulus. All right. Actually, if we look at the table, we can already say whether the table exhibits commutativity or not. So, a while ago, we looked at the inverse, no? We just look at the zeros. And now, how do we know if the table is commutative or not? Let us see. What is 4 plus 5? 9. Here. What is 5 plus 4?
9.
Where is 5 plus... 4 plus 5 is here. And 5 plus 4 is here. Okay. What about 6 and 1? So 6 plus 1 is 7, and 1 plus 6 is 7. How about 9 and 8? 9 and 8 will give you 5, and 8 and 9 will give you 5. What do you notice? What do you notice? How do we check whether a table is commutative or not? Yes, Ronnie?
Do you know that a table is commutative if we interchange the rows and the column and the elements will be the same?
Okay, so if we interchange, actually they are, what do you call this? Symmetric with respect to the diagonal. Let me show you this table. This is actually our addition modulo 12. If we highlight the diagonal, now it will be easier for us to see. Did you notice that they are symmetric with respect to this diagonal?
Yes.
Okay, that's commutativity. And this one exhibits the inverse almost. So it's clear from the table that the inverse of 6 is 6 because we have a 0 there. And the inverse of 8 is 4 because we have a 0 there. Now, what if I assign a color to each of the elements in the set? Will I arrive at a specific design? Let's see. Isn't that interesting?
Yes.
Okay. Let's take a look at some more works. This one was done by a former student of mine. Okay. This is actually addition modulo 8. Oh, this one. She assigned a design to every element. Okay. Right? Would you like to make your own artworks? Okay, so let me group you into 3. Okay, let me group you into 3. This will be first group, second group, and third group. I'll be giving you materials.